Okay, so today we're going to look at interior angles of a triangle. And this is going to be true for any triangle, no matter the size or dimensions. Um, so it's called the Angle Sum Theorem, okay? And a theorem is a statement in math that can be proven. Um, so it says we know that the sum of the three interior angles, so write the word interior here, interior angles in any triangle always equals, and this is the important part, 180. Okay, 180 degrees. And next we have two proofs, two separate ways of proving why it's true or why it's true. We'll just do one of them. We'll do the first one. And I think that should be enough to prove to you that this would always work. It says, in 1 and 2, use what you know about parallel lines cut by a transversal to help prove that the sum of the interior angles of a triangle is always 180. Okay? Again, this is important, so I'm going to make sure we go through it, at least one of these proofs, and we'll do the first one. So we start off with line A is parallel to line B. So here's line A and line B. And they tell us they're parallel. So to show that, I'll put those little inside marks there. And then it says, prove that the sum of the interior angles in triangle CDE is 180 degrees. Okay? So we're going to prove that it's 180 degrees. Okay, well, let's do it. So they tell us we have two transversal lines. Do you guys see them? Remember what transversals are? They cut the parallel line. Here's one, line CD. This is a transversal line. Where's the other one? Which is the other transversal line?
C and E.
CE, yes. That we label the line CE. That's the other line that cuts through. Okay? And they all meet at that point C. Okay. So they also give us some measurements here, 62 and 35. All right. So now take a look. What do you notice about angle 1 and angle 62? Or this angle that's 62 degrees, CDE. So angle CDE. Angle 1 and angle CDE that measures 62. Would you say they're congruent? The same measurement? I'll give you a hint. They're both on the inside of the parallel lines, and they're on opposite sides of this transversal line. So if they're on the inside and on opposite sides of this parallel, they're called alternate. And what's another word for inside? They're alternate interior angles. So they're congruent. So that tells me if this is 62 degrees, guess what? So is this one. Okay. So it says, I know the measurement of angle 1 is, well, I could say it's 62 degrees. And it's basically because angle 1 and angle CDE, that's the name of this angle, CDE, are alternate interior, so they're congruent. So angle 1 and angle CDE are alternate, I'll abbreviate it, interior angles. So they are congruent.
What's that word after alt?
Alt-int.
Oh, interior.
Alternate interior. I abbreviated. Alternate interior angles. So that was a nice little trick. We just proved that this angle here is the same as this angle here. Okay? Take a look at angle 3 now. Because the next one they want us to look at is angle 3. Look at angle 3. Okay? So angle 3, what's the connection with angle CED? CED, the one that measures 35.
DEC.
What's the connection? In other words, are they alternate exterior? They're alternate interior again to this transversal. These are equal. This angle is the same measurement as this angle. They're alternate interior to each other. So for the same reason, but with different angles, we could say that the measurement of angle 3 is 35 degrees. Oops. I want to use this color. Okay. And then we'll just say angle 3. And what's the name of this angle again that's 35 degrees? CED. Angle CED are alternate interior angles. And if you're wondering, what kind of stuff do we learn in geometry? You're looking at it right now.
Does it matter if you put it as DEC or it has
Yeah, it does. It has to be CED. Remember we talked about naming angles? The vertex has to be the middle letter.
Yeah, but like, does it matter?
You could do DEC.
Oh, okay.
You could do DEC. But E has to be the middle one. So they are congruent. Basically, we're building up a mathematical argument to prove something we want to prove. All right, last one. It says I know angle 2. This angle 2. I'll give you a hint for this one. All right. Look at angle 1, 2, and 3 together. Santiago, pay attention here. Look at angles 1, 2, and 3 together. They add up to what number? Would you agree that all three together add up to 180? They form a straight line. A straight angle, we call it. So basically 62 plus 35 plus angle 2 is 180. So let's figure out the actual measurement since we can work that out. So we just said that we could put 62 plus 35 plus angle 2 equals 180 because they make a straight angle. So we can just work that out. Let's see. That would be 97. 62 plus 35 is 97, right? Let me simplify that down. 97 plus angle 2 equals 180. And basically, all I have to do now is subtract 197, take away 97 from 180, and that would be angle 2. And that would be what? Help me out. 180 minus 97.
Oh, 90, 93.
83.
Oh, 83. What do you
83. 83. It's 83. So this is 83 degrees. Okay? All right. So let's do it. We know now that this is 83 degrees. Okay? So basically, we want to say angles 1, 2, and 3 form. When they make a straight line like this, we say they form a straight angle. Okay? So basically, we just showed that these three angles are those measurements. And let me just add this amount here. We know that this is 83. So take a look now. Look what we just proved. We just found that this angle here is 83. What does 62 plus 83 plus 35, what do they add up to? 180. Now there's nothing special about the fact that I had 62 and 35, excuse me. Nothing special about that. Imagine that I could take this, and I wish there was some feature that would allow me. Imagine I could take this top line, okay, and move it around. So I can make it bigger, smaller, go that way, go this way. Would you agree that I could form any triangle I wanted?
Yes.
And the numbers would change, but the relationship would stay the same. And you would always have these angles adding up to 180. Okay? So basically, we just proved that the sum of the interior angles of a triangle is 180 because we can recreate this situation with any numbers we want. And it would still add up to 180. Okay? So let's just write our conclusion. So I want to use the language they used here. So the conclusion is the sum of the interior angles in a triangle is 180. That's the important part. Because the interior angles can be reformed and still add up to 180 degrees. Okay? All right. So at this point, let's just assume any triangle, any size, any format, as long as it has three sides, it's a proper triangle, it always adds up to 180. Okay? So we're going to skip this one. This was another proof. Apparently these folks like proving, which is good. It's good practice, but we don't have the time. And this is the type of things you do some of in geometry. Okay? Let's talk about the other thing you do some of. You take the fact that you learned or proved and use it. So that's what we're going to do next. We're going to flip the page. We'll skip this one too. This was kind of a practice with those skills. But the main thing we want to practice is this. Okay? So we'll start with number 4. We're going to do 4 through 7 together, okay? It says, use what you know about the sum of the angles in a triangle to set up and solve an equation to find the value of x Then find the measure of each missing angle. Okay, so here we have a triangle, and it's a right triangle. I know it's a right triangle because they got a right angle. And next week, I believe, we'll be doing a lot of work with right triangles, believe me. All right, so we have this right triangle, and we have a right angle. So let's start with a right angle, because what's the measurement of this right angle? 90 degrees. Always 90 degrees there, okay? And they're asking us to form an equation. We'll do that first. And also find the measurement of the angle. So we're going to figure out what x is. But we already know the measurement of angle B, this one. What does angle B add up to? Or what is the measurement here? 90 degrees. That's 90. That one they gave to us. The other two we got to put in a little work for. Okay? So what we're going to do is we're going to use the fact that all three angles add up to 180. Okay? Let's start adding them up. So we have 5x plus 5. That's angle A. Plus 90, angle B. Plus angle C, which is 3x plus 5. That has to add up to 180. Okay? There we go. That's the equation we're going to use. And it just has a bunch of terms. But we've done this before. Add up the x terms, add up the constants. You end up with a two-step equation. So let's do it. Let's use this space to solve it. Okay? Let's see here. We got 5x and 3x. That's going to be 8x. Then let's add up the constants. 5, 90, and 5. That's 100. So we end up with 8x plus 100 equals 180. Subtract 100 from that. You've done that before. This over here, 8x. 180 take away 100 is 80. So what does x turn out to equal? 10. It's basically 80 divided by 8 or 10. X equals 10.
Does that mean? Wait, I don't know.
Well, that means we could figure out the measurement of those other angles A and C that we don't know yet.
Oh, because we placed the x
With the 10. So let's do that. We're going to replace 5 times x with 5 times 10 plus 5. So that's 50 plus 5. That's 55 degrees. So angle A is 55 degrees. And then do the same thing here. It's 3 times 10 plus 5. So this is going to be 3 times 10 plus 5. So that's 30 plus 5, so it's 35. Boom. We got our answer. Okay. Any questions? So you're just using the fact that all three angles add up to 180. All right, let's try the next one. We got three angles. They add up to 180. This time they tell us that's 68 degrees. Okay. Excuse me. So let's go ahead and set up an equation. Let's add angle D, 13x minus 3. And then angle E, so 6x plus 1, plus angle F, which is 68, and that equals 180. Okay. Any questions?
Do we do it ourselves?
Yeah, let's try it. Give it a shot. Combine it. So take it from here. Let's see if we can figure out x. All right. So if you simplified this down and you got this far, 19x plus 66 is 180. You're on the right track. Let's take it from there. So now that we know that x is 6, let's fill in our angles. Which one do we know? Angle F. That's 68. So angle F is 68. So let's figure out angle D. So for angle D, we're going to do 13 times 6. And then take away 3. All right. And that's 78. There's 3. So the answer is how much is that?
What? Oh, 13 times 3?
78.
I mean 6. That's 60, 70, 75.
75.
Yeah.
75 degrees. And over here, we're going to have 6 times 6. That's 36 plus 1, 37. All right. Okay. Let's do the next one. So go ahead and set up the equation. Remember, all three add up to 180. Okay. I'll give you some time to set it up. Try it on your own. Okay, so let's do the last one. They're giving us a word problem. It says a triangle JKL. Angle K is 3 times the measure of angle J, and angle L is 8 times the measure of angle J. Find the measure of each angle in the triangle. So let's make a draw triangle, and we will label it JKL. All right. So it says angle K is 3 times the measure of angle J. 3 times. So it's 3 times J, right? So let's make angle JX. We don't know what it is, but we know that it's angle K is 3 times that, so this would be 3x. Do you see how I got that? K is 3 times the measure of angle J. I'm calling J x, so this would be 3x. Then it says angle L is 8 times the measure of angle J. So what am I going to make angle L?
8 times the measure of 3.
8 times the measure of J.
Oh, J.
So since J is x, what would it be? 8. Well, it's 8 times though. 8x. So we just got our 3 angle measurements as expressions. we got x, 3x, and 8x, and that has to add up to 180. Okay. And so what is that? 12x? Okay, let's divide by 12. And so how many times does 12 go into 180? 15? Oh, what? Let's just check. When in doubt, 180 divided by 12, 15. So that means this is 15 degrees. So angle J is 15 degrees. Angle K is 3 times that, so that's 45 degrees. And angle L is 8 times that, so that's 120. There it is. Okay, so the assignment will be on Cami.